GIS data collection. Data collection is the process referred to the sources and information we gather, aimed at specific parameters in order to insert them in GIS and create. It is also a time-consuming, tedious, and expensive GIS activity. Data collection is split into data capture and data transfer, which I will discuss later. Data collection is subject not only to GIS but is a wide process regardless of the field of study. However, while GIS is growing up, the process of data collection becomes more and more demanding and has been evolved into a subcategory of science with methods targeted at collecting data for GIS. GIS data transfer and data capture. GIS data capture is a technique in which the information on various map attributes, facilities, assets, and organizational data are digitized and organized on a target GIS system in appropriate layers. GIS data transfer was designed to be a robust way of transferring Earth reference spatial data between dissimilar computer systems with a potential for no information loss. There are two main types of data capture. First is the primary data sources, which are those collected in digital format specifically for use in a GIS project. Second is the secondary sources, which are the digital and analog datasets that were originally captured for another purpose and need to be converted into a suitable digital format for use in a GIS project. These are the data collection workflow. First is the planning. Planning includes establishing user requirements, garnering resources, and developing a project plan. Preparation involves obtaining data, redrafting poor quality map sources, editing scanned map images, removing noise, setting up appropriate GIS hardware and software system to accept data. The digitizing and transfer are the stages where the majority of the effort will be expended. Editing and improvement covers many techniques designed to validate data as well as correct errors and improve quality. And the evaluation is the process of identifying project successes and failures. GIS analysis. Analyzing data in a GIS ranges from simple mapping to creating complex spatial models. A model is a representation of reality used to simulate a process, predict an outcome, or analyze a problem. The phrase GIS analysis encompasses a wide variety of operations that you can do with a geographic information system. This ranges from simple display of features to complex, multi-step and analytical models. The types of GIS analysis are showing the geographic distribution of data, querying GIS data, overlaying different layers, and complex analysis. Showing the geographic distribution of data. Perhaps the simplest form of GIS analysis is representing the geographic distribution of data. This is conceptually the same as sticking pins in a wall map, a simple but powerful method of detecting patterns. As you can see in the attached image, the map is the analysis. For example, a police department might analyze burglary patterns by plotting the addresses of reported break-ins. The department could make the map more informative by displaying the incidents with different symbols to show the time of the day, method of entry, or types of valuables reported stolen. Another type of GIS analysis is querying or selecting from the database. Queries let you identify and focus on a specific set of features. There are two types of GIS queries: attribute and location queries. The attribute queries, or spatial queries, find features based on their attributes. The police department mentioned earlier could use an attribute query of its database to obtain a table of crimes that fall into a particular category. This image are the results from a query on the CrimCat field, showing records where the value in the field is 9. The map shows the results of the query. The next type is the location queries or spatial queries. It finds features based on where they are. The police department could use a location query of the database to find crimes that occurred within a given area. One way to do a location query is by drawing a rectangle on the map, as you can see on the image. Here, the police department has selected only those crimes that occurred within the rectangle. These crimes could be studied together to determine if any of them are related. The police department could also do more complex spatial queries using polygon features, such as census tracts selected from another layer. One of the most useful features of a GIS is that you can see the results of both spatial and spatial queries on the map. Overlaying different layers is a type of GIS analysis that you can create new information when you overlay one set of features with another. There are several types of overlay operations, but all involve joining two existing sets of features into a single new set of features. For example, a farmer wants to find how much land can be planted with a new crop. The crop can be planted on hillsides and needs soils that are highly permeable. The farmer combines in a union overlay two existing layers of data about the farm, polygons of the ground surface classified by slope and polygons of soil permeability. The farmer can now select the new polygons that have low slopes and high permeability. The last is the complex analysis. When doing a complex analysis, you can combine all of the mentioned techniques earlier and many others in a complex GIS analysis. With a GIS, you can create detailed models of the world to solve complicated problems. Because GIS can perform these operations rapidly, it is possible to repeat an analysis using slightly different parameters each time and compare the results. This can allow you to refine your analysis technique. I've provided and discussed a brief overview only of some of the common types of GIS analysis, and that is all for this report. Thank you.